So again, we're on the back of this here 6 remainder and factor theorems note sheet. We're going to start up today on number 10 on the back and discuss what happens when I'm trying to find something besides just doing synthetic division. So for instance here, it says find a value of k so that the remainder is 6 when, and they give me this value. I'm going to set this up just like I would any synthetic division problem. Again, if they give me a binomial, I take the opposite because the 0, of course, would be if I did x minus 5 equals 0, my 0 would be 5. That's what I want to divide by. And this is the part that's going to get a little odd. We're going to throw a variable in the middle of this. Still going to be nothing too bad to work with, though. I'm still going to bring my first term down, do this like I have been doing all of these. Still going to multiply and add. Kind of looking at this going, okay, this is kind of weird. Multiply. What? And you're, Now that's going to become the question here, because we want a remainder of 6. If the remainder is 6, now this kind of becomes a puzzle. What number is this going to be if this number is 6?
That's going to be negative 13.
Okay. So, if that's negative 13, let's see here. What could I do? Oh. What could I do? Yes, sir.
Replace k with negative 3.
Okay. Right, because I'm looking at this and I'm trying to figure out, because remember, whatever value is here, it's going to need to be multiplied by 5, to get negative 13. Yuck. So let's see. Let's kind of keep working backwards here. What's this value going to need to be?
Negative 2.6.
Negative 2 3/5.
Okay, negative 2 3/5, negative 2.6. Either one of those would work. So basically I'm like, okay, this works for this works for this, and we're finally back to this k value that we're looking for. So how do I find the k value now? What?
K minus 10 is equal to
K minus 10 is equal to negative 2 3/5, or negative 2.6. Add that 10 over. Yuck. We hope this doesn't happen too often with these crazy numbers, but it can sometimes. But that's kind of the process we're using. We're going to take our knowledge of synthetic division to start figuring out pieces, and then we can slowly start working our way backwards until we can get back to the k value. Because again, if it's a whole number, I guess you could play guess and check for a while, but I don't think you're going to be guessing 7 2/5 anytime soon. So that's one of the ways that we can use synthetic division to kind of help ourselves out. The other thing I can do is kind of work my way backwards. For instance, write a polynomial function that has a double root of 2 and a root of negative 3. Graph the function. More than one answer is possible. Okay? A double root would be something like, and this isn't going to be the one that you guys want to see, but you can see an example at least this way. When we talk about double roots, they're called bouncers. For instance, that would be a double root, because what it does is, instead of like a normal x-intercept that goes all the way through my axis and then goes to the other side, like this one does and this one does, this one hits the x-axis and bounces off and goes back up. So that's actually 2 solutions. So in this case, I think that's at negative 3, would actually be negative 3 and negative 3. It's 2 legit solutions. What I'm trying to do now is come up with a polynomial that's going to do that, but the root's going to be at 2. So here's how this works. When it has a root of 2, what does that mean? What that means is I'd have x minus 2 quantity squared. Well, how do you know that? Because remember, a root is an x-intercept. When I'm trying to find an intercept, I take each of my binomials, set them equal to 0, and find out what my x value is. So if a root is 2, it would be x minus 2. Double means I square it. And a single root of negative 3, but remember, it's that opposite sign because x plus 3 equals 0. I'd find out that my root, or my intercept, is negative 3. So once I get this, now, since it says polynomial function, we actually want to multiply this out. So I'd probably clean this up first. And again, when you're squaring this out, don't just do distribute, distribute. It's x squared plus 4. That doesn't work. If need be, physically write it out. There's 2 of them. That's what the squared means. And then you'll be sure that, yes, you will get x squared. But you'll also get, as you FOIL it out, a middle term, which you have to have or you're not going to get the right answer. And I've noticed a few more of you using this as I've seen homework come in, and I've always used this as a good thing with my regular Algebra 2 classes. Once you get past foiling, once you get past 2 binomials and get into like a trinomial or maybe 2 trinomials, I'm a bigger fan of giving myself a visual to use so I don't forget a part. So what I tend to do is I make a box. And again, if some of you are content with just distributing it out, that's fine. But the nice thing about this little organizational tool is, as you multiply the sides together to fill in your box, it's going to automatically put your like terms together for you. So it's kind of even like a safety net to see, am I doing this right? So as I get towards the end then, I'm like, oh, start with x to the third, okay. There's my like terms with my x squareds. Again, only messing with the coefficients. Don't mess with the exponents anymore, because now we're just combining like terms. Negative 12 and 4 is negative 8x plus 12. That would be one way I could write a polynomial function. Some of you are like, well, what else would you do? I could stick a coefficient in front if I wanted to. I'm not sure why I'd want to, but I could. So when I'm graphing, and I would just do a sketch of this, it's going to let you see that bounce that I talked about before. So if I type this in, and again, it's a degree 3, so I know there's 3 solutions, the double root of 2 and the 3. But it kind of gives us a chance again to look at, momentarily here, how sometimes we can get deceived if we don't know what's going on. Like here, normally, you'd look at that and you'd say, oh, just looking at it, there's 2 solutions. But then you'd be like, well, wait a minute, though. This says x to the third. Is the other one imaginary? If you did your synthetic division through, you'd get the same answers back again. You'd be like, crap, I'm doing something wrong. No, you're not. If you see a bounce, that's where your double root is, your double answer is. In this case, it's at 2, and then my other solution's over here at negative 3. So if I were making a little sketch here, I'd say, okay, making sure that I get that double root bounce at 2, and that I get that single one at 3. And that's basically all I'm looking for with something like that. And that basically should get you covered for everything else that's within your assignment. So